Hello, this is Dr. Ayenshola Ogundele, Astronautics for Exploit. Lunar Mining, a path to lunar economy. The overview is as follows. Importance of lunar mining, exploitation of lunar resources, plans for lunar mining, and lunar mining proposals. Realism is beckon on the fact that lunar resources could be mined and harvested from the surface of the moon in years to come. This can be attributed to the high investment by the government, private companies, and highly interested individuals and investors. Realization of this dream will open new market, aid evolution of the lunar economy, and create wealth for the participants. The idea of space mining is growing at faster rate based on the renewed interest in constructing lunar bases on the moon and the fact that the moon contains billions of dollars of untapped natural resources. For the maintenance and sustainability of the industrial production of lunar resources, robots, and women will be of tremendous advantage if available on the moon. Mining the moon resources will create a lot of benefits for the humankind. The rare earth metals will be useful for making smartphones and medical equipment. Titanium will be useful in making titanium alloys. Precious metals such as gold and platinum and helium-3, which is a stable helium isotope and extremely rare on Earth, has the potential for fueling nuclear power plants. Several lunar mining proposals have been put forward. Examples are ablative arc mining, smelters, use of fluorine, skylight, lunar thermal mining, multi-sort electrolysis system, and autonomous robot swarms. Ablative arc mining concept is based on the idea that water, metals, and other resources will be pulled from the lunar surface material all at once. It has been proposed that smelters could process the moon basaltic lava to break it down into pure calcium, aluminium, oxygen, iron, titanium, magnesium, and silicon gas. Another proposal envisions the use of fluorine brought from Earth as potassium fluoride to separate the raw materials from the lunar rocks. Using high-resolution images taken from close-up, skylight concept involves creating 3D models of craters. Skylight proposes technologies to rapidly survey and model lunar craters. Thermal mining applies heat directly to the lunar surface at high enough temperatures to convert ice to water vapor, essentially skipping the liquid phase through a process reversed to as sublimation. A plan is being mapped out for harvesting the moon's resources using autonomous robot swarms and new excavation techniques. Importance of lunar mining. Moon resources. According to research findings, Moon, the natural satellite of the Earth, contains useful resources on top of it and beneath. The abundance of the Moon's vast and useful resources is spurring aspiring moon miners' interest. This picture shows illustration of the Moon. Lunar Reconnaissance Orbital Spacecraft, a NASA robotic spacecraft which is currently orbiting the Moon in an eccentric polar mapping orbit, collected data that are essential for planning future human and robotic missions to the Moon. Its detailed mapping program is identifying safe landing sites, locating potential resources on the Moon, characterizing the radiation environment, and demonstrating new technologies. This picture shows illustration of a future human settlement on the moon. Earlier spacecraft show that moon may be rich in metals such as iron and titanium. Evidence of metal oxides in large craters around the moon's north pole was also shown by the spacecraft. It was hypothesized that large meteors hitting the moon excavated metal oxides from beneath the moon's surface, and this therefore suggested that there's concentrations of the metal underground. This picture shows commercial use of water ice near the moon's poles and will provide access to a supply line of in-space propellant. Exploitation of lunar resources. Moon important resources. Geological surveys show that the moon contains three important resources: water, helium-3, and rare earth metals. Water is vital for supporting life and agriculture in space and can be converted into rocket fuel to propel mankind further towards the stars. This picture shows illustration of resources on the moon. Helium-3 is a rare helium isotope that could be used for innovations in the energy sector such as nuclear fusion. Rare earth metals are vital in emerging technologies as well as the technologies we make use of every day, from smartphones and computers to medical equipment. This picture shows concept of building of a lunar base. Moon mining. Moon mining requires existing infrastructure on the lunar surface. Given the presence of water on the moon, there is a potential for some form of long-term human settlement. 3D printing could be the key to infrastructure, allowing material and equipment to be manufactured on the moon. This picture shows artist's concept of a moon village. Plans for lunar mining. Various plans are being executed ahead of the mining of lunar resources. A lot of actions and plans are mapped out for the exploitation of the moon. Various proposals have been put forward for the exploitation of the moon and setting up of feasible mining operations on the lunar surface. This picture shows robotic construction of lunar and Martian infrastructure using 3D printing. SpaceX is planning and working on solving a significant cost barrier by developing reusable rockets, which could allow for cheaper transport of mined materials from the moon back to the Earth. This picture shows concept of lunar flashlight in a position over the south pole of the moon. Lunar mining colony. If the reusable rocket solution works, a lunar mining colony will have to make use of an unprecedented amount of innovative mining technologies with automated or remote control machinery and pumps that requires minimal human oversight. This picture shows a rendering of a possible lunar habitat, featuring elements printed in 3D with lunar soil. Lunar mining proposals. A number of proposals have been put forward for mining lunar resources, and some of them are highlighted as follows: Ablative Arc Mining, smelters, use of fluorine, molten salt electrolysis, skylight, lunar thermal mining, and autonomous robot swarms. Ablative Arc Mining. Ablative Arc Mining concept is based on the idea that water, metals, and other resources will be pulled from the lunar surface material all at once. This is an improved concept over the previous lunar mining concepts and methods. This picture shows an early lunar outpost design based on a model design. According to the Ablative Arc Mining concept, arcs of electric current across two electrodes will sublimate frozen water out of the lunar regolith or surface material, turning it into water vapor. It will also pull other things like metals out of the lunar material. The electric arc will then break apart the water or other materials like metals into ionized particles. This picture shows moon rocks from the Apollo 11 mission. Electric fields will guide the ionized particles into capture chambers. Then the technique will, in one fell swoop, suck resources out of the lunar regolith and collect them for later use. This picture shows concept of a lunar base. Smelters is another lunar mining proposal. Smelting is a process of applying heat to ore in order to extract a base metal. It is a form of extractive metallurgy. It is used to extract many metals from their ores, including silver, iron, copper, and other base metals. Smelting uses heat and a chemical reducing agent to decompose the ore, driving off other elements as gases or slag and leaving the metal base behind. This picture shows future of mining on the moon. Extensive lunar maria are composed of basaltic lava flows. Their mineralogy is dominated by a combination of 5 minerals such as anorthites, orthopyroxenes, clinopyroxenes, olivines, and ilmenite, which are all abundant on the moon. Raw lunar amorphite could also be used for making fiberglass and other ceramic products. The moon, as seen alongside planet Mars, is shown here. Moon basaltic lava. It has been proposed that smelters could process the moon basaltic lava to break it down into pure calcium, aluminium, oxygen, iron, titanium, magnesium, and silicon glass. Artist's impression of a lunar base is shown here. Use of fluorine is another lunar mining proposal. It envisions the use of fluorine brought from Earth as potassium fluoride to separate the raw materials from the lunar rocks. Robotic construction of lunar and material infrastructure using 3D printing is shown here. Skylight is another proposal for lunar mining. Using high-resolution images taken from close-up skylight concept involves creating 3D models of craters. Skylight proposes technologies to rapidly survey and model lunar craters. Illustration of the Skylight mission concept is shown in this picture. The models will show whether it is safe for a human or a rover to descend into and explore the futures. The system could also identify eyes in the shadows. Skylight will be very useful for the future astronauts working on the moon. Interior of a 3D printed section of planned moon village is shown here. Lunar thermal mining is another concept of lunar mining. Thermal mining applies heat directly to the lunar surface at high enough temperatures to convert ice to water vapor, essentially skipping the liquid phase through a process reversed to sublimation. The vapor will then be captured in a large onion refrosing and transported to an electrolysis plant where the ice will be broken down into hydrogen and oxygen. An illustration of thermal mining proposal is shown in this picture. The effectiveness of direct heat in sublimating ice from within icy regolith samples has been demonstrated. Proposed lunar outpost is shown in this picture. Molten salt electrolysis system is another lunar mining proposal. This is the first example of direct power-to-power processing of solid lunar regolith simulant that can extract virtually all the oxygen. Regolith is placed in a metal basket with molten calcium chloride salt to serve as an electrolyte and then heated. Apollo 17 astronaut Harrison Smith, standing beside a Buddha on the lunar surface, is shown in this picture. Instead of melting regolith, the molten salt electrolysis system only needs to heat the material to 950 degrees Celsius. An electric current causes the oxygen to leave the regolith and migrate across the salt to be collected at an anode. This process also converts the regolith into usable metal alloys. An emerging future moon base is shown in this picture. Autonomous robot swarm is another proposal for lunar mining. A plan is being mapped out for harvesting the moon's resources using autonomous robot swarms and new excavation techniques. The Human and Explainable Autonomous Robotic System, or ART, is designed to train robots to work together on mining, excavation, and building tasks. It will also allow the robots to improve their collaboration skills over time. An illustration of a lunar polar mining base with buried crew habitats, widely spaced solar power panels, propellant production plant, and depot tank farm is shown in this picture. The developers of autonomous robot swarm system for mining of moon resources envision a fully autonomous swarm of robots that doesn't need to receive instructions from the Earth to mine materials and construct simple structures. A moon-based concept of the demonstration of remote construction is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Lunar Mining, a path to lunar economy, presented by Dr. Ayenshola Ogundele, Astronautics for Exploit. Thank you.